Welcome to a presentation on absolute value inequalities. The goals of this video are to solve absolute value inequalities algebraically and also to solve them graphically. This video does assume you've already watched compound inequalities and absolute value equations. Absolute value inequalities can be rewritten as compound inequalities with and or or. This means we will be looking for either the intersection or the union of two inequalities. Absolute value inequalities fall into two basic categories. The first, where we have the absolute value either less than or equal to a positive value of c. And the second case is where we have the absolute value either greater than or equal to a positive value of c. Let's consider the first case. So the solutions of the absolute value of x less than c or less than or equal to c are those values such that x is between negative c and positive c, and it may or may not include c based upon the original inequality symbol. So this compound inequality can be written as x is greater than negative c and x is less than or equal to c. Notice the inequality involving positive c is essentially the same except we drop the absolute value, and for the second inequality we change the sign of c and also reverse the inequality symbol. In the same case, when we have less than or equal to c, it's just we use a different inequality symbol. So let's consider the absolute value of x less than 2. Remember that absolute value is a number's distance from 0. So we want all the numbers whose distance from 0 is less than 2 units. Well, we know that we could go to the right with an open point on 2 and move toward the left closer to 0, but we can't go any further from 0 on the left than an open circle on negative 2. This interval represents all the numbers whose distance from 0 would be less than 2. If we wanted to write this using inequalities, we'd have two inequalities connected with and. The first inequality would be x has to be greater than negative 2 and x also has to be less than positive 2. Now here's a way that you can remember when you have the absolute value of some expression less than or equal to c, it's going to be a compound inequality with and. Let's say you know someone who gets in trouble with the law and they're put under house arrest. What that means is the court orders an individual to always maintain a distance less than a given value. So if the court orders the distance from the house to be less than or equal to 3 blocks, we know that means that the individual can come out of the house and move to the right no more than 3 blocks. They could also go to the left 3 blocks and then stay within a distance closer than these two, so it would look like this. Now using inequalities, we'd have to have two inequalities connected with and because it would be the intersection of x always being greater than or equal to negative 3 and also x being less than or equal to positive 3. Okay, the second case is when we have the absolute value of some expression being greater than or equal to a positive value of c. You can see we're going to have two inequalities connected with or this time. The first inequality looks almost the same except we drop the absolute value, and the second inequality we change the sign of c and reverse the inequality symbol. So now if we consider the absolute value of x being greater than 2, or we want all the numbers whose distance from 0 is greater than 2 units, we know we'd have an open circle on positive 2. In this case, the arrow would go to the right. All these numbers have a distance from 0 greater than 2 units, but we could have the same case on the left, open circle on negative 2, arrow to the left. So this translates into x being less than negative 2 or x is greater than positive 2. It would be the union of these two inequalities. So here's a way you can remember that if you have the absolute value greater than or equal to a positive value of c, it will always be a compound inequality with or. Let's say you know someone who gets a restraining order. Well, a restraining order usually states that an individual cannot come within a certain distance from a person or a location. So if the court orders an individual to maintain the distance from a specific location to be greater than or equal to 3 blocks, that means they could be to the right 3 units or further, or to the left 3 units or further. So using inequalities, we would have x less than or equal to negative 3 or x greater than or equal to positive 3. Okay, let's put this into practice. Let's say we want to solve the absolute value of x minus 2 less than 6. The first step would be to determine if it's going to be an or an and. A distance less than 6 would be an and. So we'll have x minus 2 is less than 6 and x minus 2. Remember, for the second inequality, we reverse the symbol and change the sign. We need to solve these, graph these, and look for the intersection of the two. So we add 2 to both sides, x less than 8, and x greater than, we would get negative 4. So let's graph these two and look for the intersection. So let's first graph x less than 8. It would look something like this. And x has to be greater than negative 4. And that would look something like this. Now because it's an and, we're actually looking for the intersection of these two inequalities. And we can see it's going to be the interval in the middle. Therefore, our final graph would look like this. So now if we want to express this using interval notation, we know we'd have an open interval from negative 4 to positive 8. I do want to take a look at this on the graphing calculator now. So what we're going to do is we're going to graph the left side in y1 and the right side in y2. So to access the absolute value, remember you hit math, right arrow once, and then enter. So because we want to know when y1 is less than y2, we want to know when this v is below the horizontal line y equals 6. We can see graphically the v is below the line y equals 6 between negative 4 and positive 8. If we wanted to find these exact locations, we could find the points of intersection. So let's try another. The first step is to identify this will be an or because the distance is greater than 7. So our first inequality will be 2x plus 1 greater than or equal to 7, or 2x plus 1, reverse the inequality symbol, and also change the sign of the 7. So we want the union of these two inequalities. So we'll first graph x is greater than or equal to 3, close point on 3, arrow to the right, or x is less than or equal to negative 4, closed on negative 4, arrow to the left. Because we're looking for the union, this is the graph of our solution, but if we want to write this using interval notation, we would have two different intervals. The first one from negative infinity to negative 4, it includes negative 4. The second interval includes 3 and approaches positive infinity, and it's the union of these two sets. Let's take a look at this one graphically as well. So again, we'll type the left side into y1 and the right side into y2. So now we want to know when the v shape is less than or equal to positive 7. So when is the v above the line y equals 7? So here we have y1, the left side, and here we have y2, the right side. Graphically, we want to know when the v is above the line y equals 7, it's to the left and to the right. And let's just verify that this left value is negative 4 as we claim. The way we do that is we hit second trace, which brings up the calculation menu, option 5, move the cursor closer to that point of intersection, hit enter 3 times, and we can see that is the x value of negative 4, and we could also verify that the right side is positive 3. Let's try another. Now in this problem we see that the absolute value is not isolated, so our first step is going to isolate the absolute value. So we'll add 4 to both sides. This is connected by multiplication, so we'll divide both sides by 3 to obtain the absolute value of 2x is less than or equal to 3. Now we determine that this will be a compound inequality using and. So our first inequality will be 2x less than or equal to positive 3 and 2x, reverse the inequality symbol and change the sign of the 3. Let's go ahead and graph this. One thing you can do to save some time is we're going to plot 3 halves using a closed point and it's going to be to the left because it's less than or equal to. I'll just start it going left and then I'll stop, since I am looking for the intersection of two intervals. X is also greater than or equal to -3/2, closed and to the right. So we can see that the interval between will be the intersection. So using interval notation, we would have the closed interval from -3/2 to +3/2. I hope that was helpful.